right, good evening, guys. Thank you so much for your patience. Good evening to everyone that is joining us on this live as well. So we are going to be looking at Maths Paper 1 today, and I know that many of you are actually writing tomorrow. So what I'm going to do is I'll be taking you through last year's May-June exam, right? The paper 1, Maths Paper 1, so that's the 24 May-June exam. Now, I've picked out a couple of questions. I haven't gone through the questions thoroughly, but what I thought that we can do this evening is that we can go through, firstly, we'll look at functions, all right? The one question on functions. Perhaps if we have time, we can look at the other questions as well. But we can also look at calculus. I think more specifically, that is the one section that was requested. And finally, I'll look at optimization. Now, for the purpose of this lesson today, I want to make sure that at least any question that might be there. And so for those of you, for you guys, because you are joining me live, please stop me anytime. If there are any questions, I will not necessarily be able to see the questions that are coming on from online. And yeah, let's get started. Okay, right. For those of you that are watching us live, you will be able to note that we will now and then go live on our YouTube platform. But we will only do that during our exam sessions. Right, and for those that perhaps may be upgrading or you're doing your Matric and you want to get the regular lives, you have to become a part of our memberships, okay? Right, okay, so for all of you guys, my regular crew, are you guys ready?
Yes, sir.
All right, good, is nice. All right, let's get right into it. So, I'm going... Okay, awesome. All right, please stop me anytime, guys, whenever there is a question. Right, I'm just going to share my screen right now. As I said, I am going through the 2024 May-June exam. All right, and hopefully we will be able to go through the questions that are necessary there. All right, so I want to start with the question on functions. I'm going to start on question 4, if you don't mind. Right, so they say to us, we've got g of x, which is 1 over x minus 1. Okay, this is plus 2. Now note, in this case, we are given, right? Remember, this is our hyperbola, right? Our hyperbola in this case. So we know that this value here, negative 1, represents the vertical asymptote, right? So, firstly, we note that this is a is greater than 0. So our hyperbola might look a little bit like this. So we know that at positive 1, there is a vertical asymptote. We know that at positive 2, right? So note that the vertical asymptote changes sign. So if it's minus 1, it's going to be at positive 1, right? But if it is, in this case, the horizontal asymptote, this does not change sign. So it will be at positive 2. Now, what does my hyperbola look like? It will be in the first quadrant of my asymptote. It will also be on the third quadrant. So this is what it will look like. So that means that that value there will be 1 and that value over there will be 2. Now, let's quickly have a look at what they are asking us. They say write down the equation of the asymptotes for G. So our first asymptote will be at x. So for 4.1, we will have an asymptote at x is equal to 1. But another asymptote will be at y is equal to positive 2. So that's where our asymptotes will be. All right? Now, they said to us, draw a graph of G indicating any intercepts, right? So firstly, what do we need to do? We need to note what are our y and x intercepts respectively. So what happens at the y-intercept? We know for the y-intercept, x is equal to 0, right? So for this graph, so g of 0 will be equal to 1 over, when x is 0, rather g of 0. So when x is 0, that will be 0 minus 1 plus 2. So that will be 1 divided by negative 1. Sorry, that's plus 2 over there, right? Plus 2. So 1 divided by negative 1 in this case, 0 minus 1 will give us negative 1. So 1 divided by negative 1 will be negative 1 plus 2, that will give us just 1. So we know that the graph has got an x-intercept, right? The y-intercept rather. When x is equal to 0, y will be equal to 1. So, okay, I'll try and draw a clearer graph later on. And then we've got our x-intercept, right? What happens at our x-intercept? We know that y is equal to 0. So what we are going to do is take that equation, so which means g of x is equal to 0, right? So I'm going to have 1 over x minus 1 plus 2. This is all equal to 0. Are we all okay, guys?
Yes, sir.
All right, so this is going to
Yes,
be...
sir.
Okay, so that's going to be 1 over x minus 1 is equal to, now we take the 2 to the other side, it becomes negative 2, right? Now we'll write this as negative 2 over 1. And what happens? We can cross multiply, right? So we've got negative 2 into x minus 1 is equal to 1 multiplied by 1 will give us 1. And so what happens in this case? We've got, we can divide both sides by negative 2. Okay, that cancels with that. And so we've got x minus 1 is equal to negative a half. And if I take the 1 to the other side, then x will be equal to 1 minus a half. And so x will be equal to 1 over 2. So which means now we've got our x-intercept, right? Where x is equal to 1 over 2 and y is equal to 0. Now, I want us to do this. I want us to try and draw that graph. Okay, I'm going to try and draw it properly so that we can be able to see it. I don't know if I can get some more space. Yeah, maybe I'll erase this. Right. So, what does our graph look like? Okay, so there's our graph. So we've got a vertical asymptote. So we remember, we said our vertical asymptote is at x is equal to 1, right? So there it is. We said our vertical asymptote is at x is equal to 1. Our horizontal asymptote is at y is equal to 2. So there it is over there. That's 2. That's the y-axis. And that's the x-axis. Right. So what do we have in this case? We know that our a value for the graph. So our a value is this guy over here. The value that is the numerator over there. Our a value is positive. So which means our graph will be over here. And the other graph will be over there. Now remember, they said to us we must indicate where our intercepts are. So the first intercept, we said this was the y-intercept. And we said when x is equal to 0, we found that y was equal to 1. So 0 and 1. So there it is over there. This is when x is equal to 0, y is equal to 1. It's that point over there. And then the other one, we said this was, we said that's the y-intercept. And the x-intercept, when x is a half, y is equal to 0. So that is the y-intercept there, which is the point 1 over 2 and 0. Okay, it is that point over there. So those are your two graphs, okay? That's the graph of the hyperbola, okay? Right, now let's go to the next set of questions. And guys, if you don't mind, I'm just going to have to erase now and then because I'm working on the actual paper. So please do allow me to erase. Right, I hope that my sound is audible. Right? Okay. Right, let's go on to the next one. They say determine the values of x where g of x is greater than 0. Now remember, when they say g of x greater than 0, they simply mean where is our graph above the x-axis? Where is our graph positive? Right, now let's go to our graph. Where is this graph positive? Right? Well, the graph is positive for all values of x from negative infinity, right? It's positive all the way up until we get where x is equal to a half, which is over there. And then what happens? The graph is now below, right, the x-axis. So in this case, we are looking for where the graph is above the x-axis. So it's that region over there, right? So our first solution will be where x is an element of negative infinity, right? Now remember, we never include negative infinity. So in this case, all the way up until we get to 1/2, our x-intercept. Now, are we going to include that? Well, they said only greater than. So in this case, we do not include the half there because at that point, the graph is equal to 0. Right. But also, where is it positive? The moment we cross our vertical asymptote. So this is from our vertical asymptote. Now remember, we never include the asymptote because the graph is undefined there, right? So our other point is from 1, which is our asymptote. It is excluded, right? All the way up until we get to infinity. So this is where the graph of g is greater than 0. This is where the graph is positive. This is where the graph is above the x-axis. Does that make sense, guys?
Yes, sir.
All right, beautiful stuff.
Yes, sir.
Okay, awesome. Right, and then finally, they ask us to determine the equation of the axis of symmetry of G, which has a negative gradient. Now remember, we've got two axes of symmetry for G, right? The first one, anytime that you've got a hyperbola, the axis of symmetry will always be y is equals to x plus k1. This is where the gradient is positive. Another one is y is equal to negative x plus k2. In this case, this is where the gradient is negative. They asked us for the one where the gradient is negative. Now, something very important for us to note, that the axis of symmetry, the first one, let's say for the positive one, it will pass through, I want you to note there, it will pass through the intersection of your asymptotes. Now, where do your asymptotes intersect? So remember, we had a vertical asymptote at x is equal to 1. We had a horizontal asymptote, which is at y is equal to 2. So your axis of symmetry will pass through the point 1 and 2, the intersection of your asymptote. And then you also have, in this case, another, let me just use a different color. Right, you've got another axis of symmetry. In this case, again, it passes through the same point, this time with a negative gradient, right? So that's the one that we are referring to over there, right? So this is the one that they are referring to over there. So I know that it will pass a point. Which point is that? It will pass a point that is when x is equal to 1, y is 2. So let's substitute that point into that equation. So that will be when y is 2, negative, remember we've got a negative there, so that's minus x is 1, plus k2. And so let's find out what k2 is. So we take that negative 1 to the other side, it becomes positive. So k2 will be equal to 3. Okay, so k2 is equal to 3. So what we note in that case is that k2 is equal to 3, and as a result we note that our equation will be y is equal to negative x, right? So that's negative x plus 3. So that is the equation of our axis of symmetry that has a negative gradient. I hope that's clear, guys. Right. And by the way, if you were to ask me, let's say if you had to say to me, look, sir, I don't even know what to touch on, I am panicking, I'd say to you, functions are exactly the thing that you must look at. Okay, right, is there a question? Is there a question? Okay, you are a bit lost on question 4.4. All right, yes, where did we lose you?
Like where did you say y equals to x plus ky?
Okay, all right. So remember, what we said is that for the graph of the hyperbola, it always will have our axis of symmetry. So the moment they talk about axis of symmetry, know that it's going to be y is equals to x plus k1. The other one is y is equal to negative x plus k2. Now in this case, I said to you, they said with a negative gradient. So the one with the negative gradient is this one over here. Okay? So what I said to you is that your axis of symmetry will always pass the intersection of your asymptotes, right? So they'll pass the intersection of your asymptotes. Our asymptotes were at x is equal to 1 and y is equal to 2. So just simply substitute when x is negative 1, y is equal to 2. And you find the value of k2 from there, right? And so you'll find that k2, in this case, if you do your mathematical gymnastics, then it means that k2 will be equal to 3. So meaning that your equation will be minus x plus 3. Is that clear?
Yes, sir.
All right, beautiful stuff. All right, let's go on to the next one quickly, guys, for the sake of time. Now, they say to us, we've got in the diagram, we've got f of x is equal to the log of base a, right, and g that are drawn, right? Now they say to us, graph G is a reflection of f in the line y is equal to x. Now please, I want you to be very, very careful here. So when we say that a graph is a reflection about the line y is equal to x, what does it mean? It means that that graph is the inverse. Any time that you've got a graph and its inverse, they will always mirror each other by the line y is equal to x. Are you guys with me now? So what are they trying to tell me there? That G is actually the inverse of f. Okay? So we'll get back to that. Now they say to us graph f passes through the point 4 and 2. Right? Q is the x-intercept of f and r is the y-intercept of G. Right, now let's talk here, guys. They say write down the coordinates of P prime, okay? Now this is not the derivative. So this is the image of P. So if it is an inverse, if P is 4 and 2, then the image of P will actually be the points that are swapped around. So which means the image of P will be P prime, and what would that be? X is 2 and Y is 4. So what did I do? I swapped around the X and the Y values. That's how the inverse works. Does that make sense, guys?
Yes, sir.
All right, so which means that P, the image would have the coordinates 2 and 4. Now, they say to us we must show that A is equal to 2. How can we do that? Now, A, remember, in this case is the base of the log, right? So we're going to need to take a point that we know. Which point do we know? We know point P. So we're going to say f of 4 is equal to 2. So everywhere I see x, I'm going to put 4, and y will be equal to 2. So I'm going to say the log of base A of 2, x is 2, is equal to, x is 4 rather. The log base A of 4, x is 4, y will be equal to 2. Now let's find out what our value for A is. Now please, I want you guys to listen very carefully. So when I change a log rather to an exponent, the base becomes the base of my exponent, right? So that becomes the base. Now, the answer, or rather, the answer to my equation becomes the power, right? Meaning the exponent, so that's A squared, right? And then the index of the log becomes your answer. So your answer and the index actually swap, okay? So A, this guy who was the answer now becomes the index, the log, and this guy who was the index of my log becomes the answer. So A squared is equal to 4. So in this case, if I take the square root on both sides, I am going to get A is equal to plus or minus 2, but definitely this is going to be a positive base. So therefore A is equal to 2. Does this make sense, guys? Are we all good? All right, beautiful. Now let's go on to the next one. All right, I'm just going to remove this stuff that I've drawn here. So, right, they say write down the equation of G in the form y is equal to. Now we've already established that A is equal to 2, right? So in order for us to find out what the equation of G is, simply, right, it's going to be the base of the log. So y is equal to, the base is A, which is in this case 2, and in this case to the exponent of x. All right. So in this case, we are simply going to have the base being A, but we only found out that A is 2, and we raise it to the exponent of x. So that's one mark. I'm not going to bother much about it. Now, the last question on this one, they say T is a point on F, right? So remember, F is our original graph. T is a point on F in the first quadrant where TR is parallel to the x-axis. Now, I want you to note, there's R over there. So they're saying if I draw a line, right, parallel to the x-axis, right, I will reach another point, and that point is point T. Okay? Now, they say to us, calculate the area of RT P prime, right? Now, I want you to note in this case, where is our P prime? You remember, it was that point over there that we drew. So there's our P prime over there. Now, they are saying to us, find out what is the area of this triangle over here. Right. Now what do we need to do? We need to find out what are the coordinates of R so that we can be able to work out, in this case, what are the coordinates of T, and then we can find the base, right? Now, how do we find the coordinates of R? That's the x-intercept, that's the y-intercept rather, of the graph of G, right? We just found out what the graph of G is. There's the equation. So that's the y-intercept. So in this case, this is where x is equal to 0. So that means y is equal to 2 to the exponent of 0. So that means that is the point 0 and 1. Now I want you to note, guys, that as much as this is the point 0 and 1, so which means the coordinates of t, now please I want you to listen very carefully. The coordinates of t in this case would now have the same y value. Remember they said it's parallel to the x-axis. So the y value here is 1. So the question is, what would be the x value at t so that the y value is equal to 1? So remember that is now on f. So I'm going to go to my log graph and say the log of base 2, right, is equal to, where is the log of base 2, rather of x, equal to 1. Remember now we are solving for x. So what do? We said, well, that becomes the base of our exponent. The answer becomes the index. So that's going to be x is equal to, our base is 2, our index is 1. So that means that x is equal to 2. Does that make sense, guys? So 2, or rather t, has got the coordinates 2 and 1. Now I want you to note p prime has got the coordinates 2 and 4. So what does that mean? It makes a vertical line. That line TP over there is a vertical line. Now what's the distance from R to T? Right? Remember the x value at R is 0. The x value at T is 2. Right? So what is the value of our base? That's 2 minus 0. That means our base is equal to 2. Does that make sense, guys? All right. Is there a question? What's the value of our height? Our height, the y value there is 4, right? And the y value at t is 1. So what is 4 minus 1? That will give me 3, right? So to get the area of that triangle, remember the area of a triangle, you just simply say half base times perpendicular height. So the area of triangle RT and P prime will be half. Our base, we said, was equal to 2, and our perpendicular height is equal to 3, and so which means that this is going to be 3 units squared. Okay, right, so that's 3 square units. All right, I hope that was clear, guys. All right, I want to quickly move on to the next question so that we can be able to cover, as I said, I want to cover functions as much as we possibly can, right? Because this is quite an important section, and then we're going to move on to calculus. In particular, calculus, I'm going to go to calculus functions, and then thereafter I am going to move on to perhaps optimization. Right, let's go to the next one. They say to us, the graph of f of x is x squared minus 3x minus 2x rather minus 3, and g of x is mx plus c. They are drawn below, right? And D and E are the x-intercepts. So there's our x-intercepts over there, right? P is the y-intercept of f, and they say the turning point of f is 1 and -4. So I'm just going to label that point there. That's 1 and -4. They say the graph of f and g intersect at P, right, and E. Right, let's go for it. Now they say to us, write down the range of f. Now remember, when we are talking about the range, this is where the graph exists, right, vertically. So which means from the most bottom point up until the highest point. So what is the lowest point of our graph? So our lowest point, do you agree with me, would be at that turning point? Okay? So this is from -4 all the way till infinity. Remember, this graph continues all the way up. So this, our range will be, so you can either write it this way. Y is an element of -4. Now please note, -4 will be included because of the fact that once we include it, because that is a point on the graph, it does exist there, up until infinity, right? We always exclude infinity. Or you can write it simply as y is greater or equal to -4. Right, that's another way of writing that point down. All right, now let's go to the next question. Right, they say calculate the coordinates of D and E. Remember, what are those coordinates? Those are our x-intercepts, right? So we've got, in this case, the graph, okay, of f. We know that f of x is equal to x squared minus 2x minus 3. What happens at the x-intercept? This is where y is equal to 0. So which means x squared minus 2x minus 3 is equal to 0. Let's factorize that. What are the factors of 3? Such that when I subtract them will give me 2. That's definitely going to be 3 and 1. And in this case, it means that that's going to be -3. That's going to be +1. The signs would be different. And x is equal to 3 or x is equal to -1. Right, so now let's go and check. So which means at D, what is that point? That's going to be -1 and 0. I'm going to place it over there. That's -1 and 0. What about at E? That's going to be the point 3 and 0. So those are our points. So D is -1 and 0. Okay. And point E would be 3 and 0. Right, I hope that is clear. For those of you that are watching online as well, please just note that that is how we are going to get our points. Right, now they say to us, determine the equation of G. Now remember, what is G? G is the straight line graph. And they've given us that straight line graph as just mx plus c. But how are we going to get the straight line graph? We know the point at which it actually passes through. Now firstly, how do we get the value of P? That is the y-intercept of the graph. But note that the two graphs share a y-intercept. What would be the y-intercept at, what would be the point P? That's where x is equal to 0 of f. So that's f of 0. That's going to be, now I want you guys to please note, every time that you look for the y-intercept, when you're given the equation in this manner, your y-intercept will simply be that constant value. So f of 0 is equal to -3. Why? Because you'll have 0 squared minus 2 times 0 minus 3. So you'll get f of 0 to be equal to -3. So point P is the point 0 and -3. Now, can we find the gradient of our graph? Okay, I can already see what our gradient is going to be. So we're going to say gradient That's y2 minus y1. I'm going to say ye minus yp divided by xe minus xp. Now remember, you order the y's the same way that you order the x values. So you're going to have y at e, that's 0, minus y at p is negative 3. So that's minus and minus 3 divided by x at e is 3 minus x at p, that's 0. So you are going to get 1 as your gradient. I already could see that that gradient was going to give us 1. Right. So which means we now need another point to get the y-intercept. But do we really need to do that? Not really. So ideally, we were going to say y is equal to x plus c. And to get the y-intercept, we would have to substitute one of the points, right? But here's what I want you to note. In this case, we already know what the y-intercept is because we know where it cuts through the y-axis. Where is that? At negative 3. So c automatically becomes negative 3. So what's the equation of g? It means that it's going to be y is equal to x minus 3. Are we all okay, guys?
Yes, sir.
All right.
Yes, sir.
Beautiful stuff. Beautiful stuff. So they ask us the question next. Write down the values of x for which f of x minus g of x is greater than 0. So what we're going to do for this one, let's just rewrite that differently. So f of x, we take g of x to the other side. So this is where f of x is greater than g of x, right? So what am I looking for? I'm looking for where the parabola is above, right, the straight line. So let's find that out. Where is that? Okay, sorry, that's negative 1 and 0. So where is the parabola physically above our straight line? It's going to be over there. So from negative infinity until where x is equal to 0, right? Because once we get there at x is equal to 0, then your parabola is below, right? But where else is it above the straight line? Do you agree with me? It will be from this point here all the way up until infinity. Okay, right. So where is f of x greater than 0? So I'm going to say, right, I'm going to write it over, we don't have a lot of space there. Okay, I'll write the solution here because we're done with that. So this is where x is an element of, now please I want you to note, we said from negative infinity all the way until we get to 0, but they said greater than, not greater or equal to. So we're going to exclude 0, right? So x is from negative infinity till x is 0. And then this is again at E, they intersect there. So f is above, from 3 all the way to infinity. So 3 excluded because they are equal over there to infinity. Another way of writing this is saying x is less than 0 or x is great. Sorry, this was supposed to be 3 to infinity, not 3 to 0. So x is greater than 3. Okay, right. I hope that makes sense, guys. Are we okay with that?
Yes, sir.
All right, beautiful stuff. All right, now let's go to the next question. Let's go to the next question. So they say to us, determine the maximum vertical distance between H and G. Now, what is H? They say H is minus f of x. All right? Now let's find out what the equation of h will be. So which means to find h of x, now please I want you to note, we are going to say minus, but what is f of x? F of x is x squared minus 2x minus 3. So x squared minus 2x minus 3. That's h of x, right? Now, we want to know where is f of x, what is the maximum vertical distance between h and g. Now guys, I want you to note, whenever I'm looking for a vertical distance, I'm going to now set up a distance formula, right? So the distance, and they said vertical distance, right? So if I say vertical distance, it means it's only in terms of the y values. So the y value of h versus the y value of g. So I am going to say the distance in terms of x will be h of x minus g of x. I am subtracting their y values, right? Now, how am I going to do that? That's going to be minus x squared plus 2x. Remember, I'm multiplying that negative into that bracket. So minus x squared plus 2x plus 3, right? Minus, what is our g of x value? Remember, we found g to be x minus 3. So this is minus x minus 3, right? So what's the graph, or rather, what is the formula for d of x? That's going to be minus x squared plus 2x plus 3 minus x plus 3. So let's simplify that. So this is going to be d of x, that's minus x squared, plus 2x minus x will give us plus x. 3 plus 3 will give us 6. Now here is the equation of the distance between h of x and g of x. Okay. Right, now what are we going to do? They are looking for the maximum vertical distance. So we can apply calculus over there, right? So we can say, well, the derivative, the maximum is where the derivative is equal to 0. So we're going to take d prime, okay, of x and make it equal to 0. Now, what is the derivative there? That's going to be minus 2x plus 1, and this is equal to 0. So let's solve there. Minus 2x is equal to negative 2, and so if we divide by negative 2 on either side, what do we get? We get x is equal to 1 over 2. Right. Do we get it, guys?
Yes, sir.
All right. So meaning we will get the maximum vertical distance when x is equal to a half. Now I want you to note, they did say between negative 2 and 3. Is a half between those values? Is x is equal to 1 over 2 between negative 2 and 3? Is it? Yes, it is, right? Yes, it falls within that domain, right? So now, how do I get the maximum distance? All I'm going to do is substitute that value for x into the distance formula. And so that means that d of 1 over 2 will be equal to minus 1 over 2 squared plus 1 over 2 plus 6. And so what will be that value? That's 6.5 minus a quarter. So that's 6 and 1 over 4, isn't it? Okay. Or you can simply say that's going to be 25 over 4. Are we good, guys? Right. So the maximum distance So the maximum distance in this case will be will be 25/4. Now another way that you could have done this is, once you've generated this equation, you can find the turning point of this equation, right? By using x is minus b over 2a, right? And substituting your b is 1 and your a is -1. Once you found that, then you substitute. It's actually kind of the same way, right? But I like the calculus route. It always is much more neater. All right. Now, if you don't mind, I'm just going to have to erase this. Guys, I'm grappling for space here. So I hope that you don't mind when I erase this, right? Now, let's answer the next question. Right. The most important thing is that you are able to understand this. Right, now let's answer the next question. So they say to us, right, so let's go for the next one. So the next question says, given that you've got k of x, which is equal to g of x minus n. Now let me do this. Let's write down the equation for k of x. So k of x will be g of x. Now remember, what is g of x? It's x minus 3, right? So that means it's x minus 3 minus n. So they've added something that wasn't there. So k of x is x minus 3 minus n. So that's the equation for k of x, right? Now they say to you, determine n if k is a tangent to f. Right. Now, guys, what happens when something is a tangent? Now, please, I want you to remember this. So, if it is a tangent, how many times does it touch the graph of f?
Once.
Right, only once, right? So that means k of x would be kind of a graph that looks like that. So meaning there is a point, the point of tangency, right? Whatever we want to call that point. Let's call it point M, right? That point of tangency will be the point where k of x is equal to f of x. Do you guys agree? Right. So let's find that point of tangency. So firstly, it means f of x is equal to k of x, right? So remember, what is our f of x? That's going to be x squared minus 2x minus 3 is equal to x minus 3 minus n. Right, I want you to stay with me on this one. So that's going to be x squared, right? I'm going to bring the x to the other side. That gives me minus 2x minus x will give me minus 3x, right? That's minus 3x. And the negative 3 and the negative 3 would cancel each other out. And so this would be plus n is equal to 0, right? So I'm looking for the values of n. But what is happening to the solution? Remember, it only touches the graph of f once, meaning there is only one solution, which means there is only one root. Okay? Now remember, when we go to nature of roots, whenever we've got only one root, we say that roots are real, right? And when we've got real roots, we know that delta is simply equal to 0. Are you guys with me now? Right. So when I've got a tangent, I know that it will only touch the graph at one point, and where the graphs are equal, there'll only be one root. There'll only be one solution. So I'll say in this case, b squared minus 4ac will be equal to 0. What is our b squared value? That's negative 3 squared minus 4 times, our A value is 1, our C value is n, and in this case, this is equal to 0. Now, can we find the value of n? Right? So we're going to say minus 3 squared, that's 9, minus 4n is equal to 0. So if I take 4n to the other side, or 9 to the other side, that's minus 4n is equal to negative 9. And if I divide by negative 4 on either side, sorry, negative 4 on either side, I get n is equal to 9 over 4. All right. Are we good, guys?
Yes, sir. Yes, sir. Yes, sir.
All right. Beautiful stuff. Okay. Right. So there is our functions. I hope that, guys, you've been able to really understand and get the gist of it. And please maximize when it comes to this section. All right. Now, quickly, I want to move to calculus. If you don't mind, guys, I know that I've already, if you can watch my previous live, I've already gone through the laws of differentiation in this case. So you can go through that one. Although I must admit, this is a very interesting one. I think for the sake of time, though, I wanted to cover question 8.3, right? Where we are dealing with the equation of a tangent, right? Now they say to us, we've got in question 8.3, the equation of a tangent of f of x, right? Which is 3x squared plus bx plus c at x is equal to 1, right? Is this value. Now please, I want you to note in this case, can we get the point of tangency? So let's assume we've got these two graphs, okay? Here's my graph of f of x, and you've got the graph of g of x. There they are. They've got a point of tangency. Can we find out what that point of tangency is? Well, it's at x is equal to 1, but what's the corresponding y value? Now remember, both graphs are equal at that point. So I'm going to find out when y, what is y when x is equal to 1. So that's going to be 9 times 1. I'm going to substitute 1 into that equation, minus 9. Right, so what do I get? 9 times 1 is 9, minus 9 will give us 0. So which means the point of tangency is 1 and 0. Does that make sense to all of you guys?
Yes, sir. Yes, sir.
All right. So I know that where f is equal to 1, what is my y value? Y will be equal to 0. Are you guys with me now? So that means I've got 3 times 1 squared plus b times 1 plus c is equal to 0. So let's try and find that out. So that means that 3 times 1 squared, that's 3, plus b plus c is equal to 0. So if you want to, we can express, we've got two two unknowns there. So we can say that c is equal to minus b minus 3. Okay, let's call that equation 1. All right? But what else do I know? I know that this is the equation of the tangent, right? So remember the derivative.
Sir?
Yes, yes.
With these questions, is it always going to be simultaneous?
Well, it depends. It depends on if you've got the equation to be equal. You've got two unknowns. If you've got two unknowns, yes, it will be.
Okay, thank you, sir.
Right, awesome stuff. Sometimes they'll say to you, find the equation of the tangent. In that case, you will just apply the laws of differentiation. Okay, right, so on this one, we've got minus b minus 3. Now, where is the other point? Remember that the derivative of f, right, is equal to the gradient of the tangent, right? So the derivative of f in this case would be equal to 6x plus b. Does that make sense, guys? Right?
Yes, sir. Yes, sir.
Okay. But where is this derivative? Now, the derivative of f, when x is equal to 1, what is it? It will be equal to the gradient of that tangent. So meaning f prime at 1, which is 6 multiplied by 1, plus b is equal to the gradient, which is equal to 9. And so what is our value for b? Now we can find out what b is. That's going to be 6 times 1 is 6. Take it to the other side. That's 9 minus 6. And that will give me 3. Okay? Now, I know that b is equals to 3. Can I find out what the value of c is? Absolutely. I can simply substitute that. So c would be minus b. So that's minus 3 minus 3. And so c will be negative 6. Are we together, guys? So meaning f of x will be equal to 3x squared plus 3x minus 6. Happy days?
Yes, sir.
Right, beautiful stuff. Okay, quickly, I want us to go to this one. Okay, we've got 2 more questions to go through. All right, and hopefully we are able to finish on time. Right, now they say to us the graph of f of x. Once again, we've got ax cubed plus bx squared plus cx minus 5, right, is drawn below, where e is negative 1 and 0. G is 5 and 0. Okay, so there it is over there. Okay, are the x-intercepts. Now, guys, I want you to be very, very, very vigilant on this. Whenever you've got a graph where the turning point is also the x-intercept, there's a very particular way of writing down the equation of that graph. Because you can write it down as f of x, that will be a into, now I want you to note, what is our x-intercept? That will be x minus 5, that's the one x-intercept, right? The other x-intercept, please, I want you to note, where the x-intercept is also the turning point. That means I will say x, remember you change the sign, so that will be x plus 1 all squared. Are you with me? You are going to square that root. Okay. So does this make sense to all of you guys?
Yes, sir.
All right. Beautiful stuff. Now they say to you, show that a is equal to 1, b is negative 3, and c is negative 9. Now, in this case, what we are simply going to do, guys, is we already know at least one of the points, right? We know in this case, we know that x is equal to 5 over there, and that's 5 and 0, but we also know that x is equal to negative 1. So we've got a point that we already know of. But what else do we know? We know from this graph that when x is 0, so we would know this point over here. When x is 0, y would be negative 5. Remember, this guy here is the y-intercept. Are you guys with me now? So I can write the equation. Remember, I've already written that equation in that way. Let's find out what the value of a is. We know that when x is 0, y is equal to negative 5. So I can say f of 0, that's a, 0 times negative 5, that's 0 plus 1, all squared. But what is it equal to? It's equal to negative 5. Sorry that it's overlapping over there, but I hope you are able to follow. Right, so what do I have? A into 0 times negative 5, 0 plus 0 minus 5 is negative 5. 0 plus 1 is 1 squared. This is equal to negative 5. Now let's find out what's the value of A. So that's minus 5A is equal to negative 5. And so if I divide by negative 5 on both sides, A is equal to 1. So we've already proven this. Okay, right. Are we all okay, guys?
Yes, sir.
Right, now let's find the other values. All I'm simply going to do is write the equation in the manner in which I had it there. Now I know that A is equal to 1, so I can write it as x minus 5 into x plus 1 squared, right? So let's find out. Let's multiply into our bracket. So that's x minus 5 into x squared plus 2x plus 1. So let's multiply all throughout. That's going to be x cubed, right? That's going to be plus 2x squared. All right, so that's x times x, that's x cubed. X multiplied by 2x, that's 2x squared. X multiplied by 1, that's x. That's minus 5x squared. That's minus 10x, right? Negative 5 times 2x, and negative 5 times 1, that's minus 5. All right, and we are going to simply add all of those up. That's going to be x cubed. There's our x squared terms there. 2 minus 5, that will give me minus 3x squared. We've got x minus 10x, which will give me minus 9x minus 5. And that is how I will be able to prove that B is negative 3 and C is negative 9. Was that clear, guys?
Yes, sir. Yes, sir.
All right. So please don't forget about that guy being both an x-intercept as well as a turning point. Okay. Right. Now let's go to the next portion of this question. Right. I'm just going to try and make some space over there. Right. So they say calculate the values of x for which f has a local minimum value. Okay, so what is a local minimum? We are talking about the turning point, isn't it? So essentially, they want, we already know what is, in this case, one of our turning points. One of our turning points is negative 1 and 0. So we want the other turning point. So what are we going to do? F of x, how do we find the turning point? So that's x cubed minus 3x squared minus 9x minus 5. Okay, right, we take the derivative and make it equal to 0. So that's going to be 3x squared minus 6x minus 9 is equal to 0. Right, let's do this. Let's divide everything by 3. So what do we get? X squared minus 2x minus 3 is equal to 0. So that will be x plus 1. That will be x minus 3 is equal to 0. So We already know this one, we were expecting it, but what's the one that we're looking for? X is equal to 3. So they said determine the value of x for which we've got a local minimum, so that is that guy there. So that other turning point is where x is negative 3, but they didn't ask us to find a y value of it, so I'm just going to leave it at that. Are we all clear, guys?
Yes, sir.
All right, beautiful stuff. Now the next question, they say use the graph to determine the values of x for which f double prime. This is the first time in my life where I see where they are taking f double prime. Now I want you guys to remember the following. When f double prime of x, right, is greater than 0, then I know that my graph is concave up, right? And when f double prime of x is less than 0, then my graph is concave down. So over here, until the point of inflection, whatever our point of inflection is, right, my graph is concave down. So I know that my double prime, f double prime, is less than 0. And then over here, my graph is concave up, okay? Then I know that my graph is concave upwards, right? Now, whenever I do these kind of questions, guys, I want you to please note. So what am I supposed to do? I am going to get a point. Now, please, I want you to listen to me very carefully. So if we say f double prime of x multiplied by f of x is greater than 0, which means when is a product greater than 0? When the signs are the same. Now let's look for when f double prime, so the graph is concave up, as well as the graph is above the x-axis, meaning the graph is positive, right? Where's the graph both positive and concave up? Right, I want you guys to please note, where do we have concave up? We've got concave up over there, but where is the graph positive where it is concave up? It's over there. Can you guys see it? All right?
Yes, sir.
Okay. Right. And then, again, remember we still need to find another solution. We said greater than 0. What does greater than 0 mean? The signs should be the same. So we also want where the graph is negative, or rather where f double prime is negative, right? So meaning we now want where the graph is concave down, right, till the point of inflection, but the graph is also negative, okay? Where the graph is below the x-axis, okay? Right, where is that? Concave down is on the green part, but do you see all the way, this is where the graph is negative. So I need to find out what is the point of inflection, right? Because it's up until that point of inflection where it will be concave down as well as below the x-axis. In this case, of course, that's to the exclusion of x is -1. So let's find out what the point of inflection is, right? How do we find the point of inflection? We found the derivative in the previous one. So to find the point of inflection, this is where f double prime is equal to 0. So f double prime of x, this is going to be 6x minus 6 is equal to 0. So 6x is equal to 6. Divide by 6 on either side. X is equal to 1. So which means our point of inflection is where x is equal to 1. So let's find out. So from negative infinity all the way till x is equal to 1. So our solution, right, so our solution will be, okay, where x is an element from negative infinity till x is equal to 1. We do not include that point, but remember, x cannot be equal to negative 1. Why? Because at that point, x is actually, or rather the graph is equal to 0 there, right? They didn't say greater than or equal to 0. They just said greater than. But x cannot be equal to negative 1. But where else is the graph? We said over that positive, we said it's this region over here. So it's where x is greater than 5. So we can also say that this is where x is an element of 5 to infinity. All right. I hope that is clear, guys. This is very important for us to note. All right, and let's go for the last one on these functions. Right, so now on the next one, okay, they say for which values of t. Guys, are we okay? Are we okay so far?
Yes, sir. Yes, sir.
All right, beautiful, beautiful. Okay, right, now I want you guys to please note, they say for which values of t will the graph of p of x equal to f of x plus t have two distinct positive roots and one negative root. Now, I want you to please note this very carefully, right? Now, so what we want, so essentially p of x is the graph of f of x plus t, but what are we doing to t? We are taking t, so t is a shift on the graph of f of x. So we are asking ourselves the question, how do we need to shift the graph of f such that it will have two positive roots and one negative root? Now let's go back into our graph. Okay? Right, let me remove all of this stuff. Right. At the moment, what is our graph looking like? It's got only two roots. One which is negative and another one which is positive. That is at E. But what do we want to have? We want to have two positive roots. Now, that means, and one which is negative. Now, I want you to note, I would need to take the graph upwards. I want you to note that, right? So that this point over here sits there. Now, what would happen to my graph? It would look something like this. Do you guys agree?
Yes, sir.
Okay, so when I shift the graph upwards, now by how much would I need to shift it? I would have shifted it, you remember that this point here was -5, right? So if I shift it up by 5 units, then it means that in this case, how many roots do I have now? I've got 1, I've got 2, I've got 3. But the problem is my root is not positive. My root is actually only, my root is 0, and I've got one negative and I've got another one positive. Does that make sense, guys?
Yes, sir.
But I want you to note, if I can shift it up even further, what begins to happen to my graph? Do you see that I start having what? 2 positive roots and 1 which is negative. Can you guys see that?
Yes,
Right?
sir.
So if I can shift it up by a value that is greater than 5 units upwards, then I start having that condition. However, I cannot shift it up so much so that I have this situation. Right? I can't have that situation. So, what was my minimum value over here? I would need to find out what that minimum value is, right? Because I can't shift it up by whatever the units are on this value. So what I'm going to do, please, I want you to find out for me what is the value of f when x is negative 3. Please help me out with that. So that would be negative 3 cubed minus 3 times minus 3 squared minus 9 times negative 3 minus 5. Can you please give me that value quickly?
Negative 32.
Negative 32.
Yes.
All right. Beautiful stuff. So that value is negative 32 over there. So in this case, I can elevate my graph upwards between 5 units, right? Greater than 5 units, but I can't elevate it beyond 32. Why? Because I now begin to have what? Only 2 roots. And what did I want? I wanted 2 distinct positive roots and 1 negative root. Does that make sense, guys? So what can I say? That this value t here is a shift such that t must be any value that is greater than 5 units, but must be any value that is less than 32. Does this make sense, guys?
Yes, sir.
All right, beautiful stuff. Guys, I really, really do hope that in terms of our functions, really we got this. Né? Right, I want to quickly run to this question. If you're not really too savvy with doing questions on optimization, I want you guys to please not to panic. Firstly, they'll always ask you questions where you need to prove something, right? Now, obviously, to prove, we'll have to work within the diagram like I'm going to do in this case. And then secondly, they are going to say, calculate the maximum whatever or the minimum whatever, or calculate the value of x such that something is minimum. So all you simply do is you take the derivative of what you've proven and make it equal to 0. So please, not all is lost if you are not able to prove this, okay? Some of them can be really challenging, but don't you worry about it. Okay, now let's go for this question very quickly. Now they say EHGF, right, is a rectangle. HE is x squared centimeters. So there's HE over there. All right, so that is x squared centimeters to n. Oh, okay, sorry. So they said HE is produced, sorry. So HE is produced x squared centimeters to n, all right? So HE is produced to n, so meaning that when we look at NE, that's equal to x squared. So NE is the one that's equal to x squared. And then they say EH is produced x squared centimeters to P. So again, that's going to be x squared over this side. They say NF produced intersects PG, right, to M. All right, so they say NF, where is NF? All right, okay, PG at M, okay, so they are simply saying that's a straight line over there, all right? And then to form an isosceles triangle MNP. All right, now we've got an isosceles triangle there with NM equal to MP. D lies on NP, okay, such that MD is perpendicular to NP. Right, so essentially, guys, they are telling us all that we are seeing in the diagram. Né? Right, now they say to us NP is 4 centimeters. Right, so we've got the entire side there, which is 4 centimeters. And then they say that MD, where is MD? Right, so which is this height over here is 3 centimeters. Right, now they say to us, show that the area EFGH is given by that entire expression over there. Right, now I want you to note, guys, you must be able to work within the diagram, right? Now, here's the thing that they did here. Okay, so firstly, what would be the size of EH? I want you to note, it would be 4 minus x squared minus x squared. So EH is equal to 4 units minus, I want you to note, 2x squared. Does that make sense to all of us, guys? All right, beautiful stuff. And then now, what we also have, guys, and I want you to please note in this case, we know that the height there is given to us as 3 units, right? But what else can we actually do with that triangle? We want the area here. So when we look at this, and I'm going to show you just now. So we've got a triangle over there. We've got a rectangle over there. Okay, right. Now, if we wanted to, what we can actually do is that we can either say, well, it's the entire of that triangle, right, minus this smallanyana triangle over here. Now, they said this is going to be the base. They called it B, right? Now, in this case, guys, I want you to please note, and this is what I'm saying to you. When it comes to these questions, sometimes they can go from easy to more difficult, or they can go from, sometimes they are very easy for us to just quickly just obtain. Right, now, when I look at this, okay, so when I look at this, I know that if I take that entire triangle, right, that's going to be half of the base multiplied by the perpendicular height. But I also can subtract this entire thing over here. Now, okay, let's go for EH. So let's say FE is equal to B. So if I'm looking for the area of EFGH, that would be equal to the area of the rectangle, which is going to be length multiplied by breadth, right? So this is going to be B, or rather the length in this case would be 4 minus 2x squared multiplied by B. I hope that is clear to all of us, né? Right, now, the problem here is that, okay, I'm trying to just quickly show you. If I look at the sides that are given to me, they gave me that NP is equal to 4, right? So this NP here is equal to 4. And they gave me that this side MD, which is over here, All right. Sorry, that's NP is equals to 4, which is that entire side. Now, if it is perpendicular, then in this case, it means that it must also bisect that side. Okay? So if I'm looking at ND, right? If I'm looking at ND, that would be, in this case, equal to 2 units. But also, I want you to note, there must be a ratio that we have over there, over the ratio that we have over there, right? So if I look at that ratio, that's going to be 4 over 3, okay? So you've got 4 units at the bottom there, and you've got 3 units at the top there. Now, in this case, guys, I want us to please note, when it comes to, in fact, I'm trying to find a way for me to make it less complicated. In fact, I think the more I say, the more complicated it would become. So what I want you guys to please note in this case, maybe without necessarily being able to do the proof thereof, right? Because it might take us a little bit of a while, and I'm looking at time. Right. So you should be able to prove, in this case, just using the other triangle, right? We know what the length, or rather the height B is, right? In comparison, or in this case, you can say that this guy over here would be 3 minus that B, right? So the height is 3, and so that guy would be, this guy here would be 3 minus the B, right? Okay, so what we can do is that we can work out that little height over there, okay? And in this case, we can find an expression for B. But for the sake of time, ladies and gents, I do want to actually continue with this question, but because I'm running out of time. So they say to us, calculate, I have to finish at 8 o'clock. Right, so they say calculate the maximum area of the rectangle. So once you've been able to derive this equation, right, all that you need to do is take the derivative, right, a prime of x, and make it equal to 0. So remember, once you've got the area in terms of that equation, so I'm going to take a prime, this is going to be 6 times 2, this is going to give us 12. So that's going to give us 12x minus 3 times 4, that's going to be 12x cubed, and this is equal to 0, right? So what I'm just simply saying, ladies and gents, is that it's unfortunate that we don't have much time. I do want to finish in this case. So that's 1 minus x squared, right, which would be equal to 0. And so you can see this is the difference of 2 squares. X is equal to 0, or x is equal to plus or minus 1. Now, I want you guys to please note in this case that we are looking for the maximum area. Of course, there's no way that I can get a maximum area where x is equal to 1, and my dimensions cannot be negative, so which means that I will substitute for positive 1 into the original equation, minus 3 times 1 to the exponent of 4, and in this case you substitute that and you get the final answer. Right, sorry guys, I think for the sake of time, I was trying to get to this, to the derivation of this. Perhaps I'll post it another time, but I think because of our time, we are really out of time. So what I'm going to ask you to do, guys, for tomorrow, please don't panic about whether all of these sections. Always make it a point, and I'm going to leave our session right here. Always make it a point that when you arrive at the exam, start with the section that will firstly give you, confidence. Start with that section that you know you are confident with, and in that case, move along as you go, right? And then finally, just another thing just to say, for those of you that are joining us from our YouTube channel, please note that we will have these lives during our exam sessions. However, for those of you who want more lives, we are going to actually have them through our memberships. Okay, you can join in as a member on our YouTube channel, but also for those of you that may want to join our grade 12 classes, just like these guys that are here are, you are more than welcome to get in touch with us at info@mlungisinkosi.co.za. All right, I want to leave it here. It's 8 o'clock, guys. Sorry that for that last question we were not able to really finish. I was really scrambling in terms of time, but we will meet again next time, which is on Saturday for paper 2. From me for now, I'll see you guys next time. Sharp, sharp. Bye-bye, guys.
Bye, sir.
All right. Awesome.